Hello, it's great to see you all again. You've probably heard scary stories about elevators falling freely, and that terrifying image makes many people anxious when stepping into an elevator. Have you ever wondered if elevators are as prone to falling and as dangerous as we often think? Welcome to Amazing Anomalies. The misunderstood elevator. First, let's understand how elevators work. A simplified model of an elevator can be represented as what you're seeing. An electric motor rotates a pulley connected to a cable to lift and lower a cabin carrying people or goods. Every time the cabin goes up, a counterweight goes down, and vice versa. This counterweight may seem useless, but it's what makes the elevator operate stably, safely, and efficiently. Imagine if the motor were directly connected to the cabin. Lifting and lowering the cabin would require a very large torque. Additionally, an extremely powerful braking system would be needed to keep the cabin stationary or lower it slowly. And if this braking system failed, it would be a disaster. But what if you installed a counterweight? If two equal weights are attached to each end of the cable, the system will be perfectly balanced. The motor then only needs to operate gently to tilt in one of the two directions, depending on whether we want to go up or down. However, in a real elevator, the load in the cabin changes constantly depending on the number of people entering and exiting the elevator, but you can't continuously add or remove weights on the counterweight. The best way is to pre-build a counterweight with a weight equal to the cabin plus half of the maximum load. For example, if the maximum load is for people, then the weight of the counterweight will be equal to the weight of the cabin plus the weight of two people. When the elevator is fully loaded, the imbalance will be equivalent to the weight of two people. When the elevator is empty, the imbalance is also equivalent to the weight of two people. In this way, the elevator's imbalance is controlled to always be within half of its maximum load. But in reality, elevators are usually always loaded, and this load is often close to half of its capacity, so it always operates in the most balanced state. Let's count the safety devices available for a modern elevator. On the motor shaft, there is a wheel. This wheel engages with a brake arm through an electronic system and a spring. The spring will brake when the elevator stops, and the electromagnet will release the brake when the elevator is in motion. When there's a sudden power outage, the electromagnet stops working, and the spring pushes the brake shoe to tightly hug the wheel, helping the elevator stop safely. Next to this braking system is a worm wheel with a very high gear ratio. It converts the high speed and low torque generated by the motor into low speed but very high torque, ideal for elevator operation. Moreover, it's a self-locking mechanism, meaning the circular gear below cannot make the worm gear rotate in the opposite direction. In other words, if the elevator is going up and loses power, the worm gear will stop rotating and brake the cabin, preventing it from falling in the opposite direction. Elevators, as you see in movies, are suspended by many steel cables. In principle, any of these cables can withstand a load greater than the combined weight of the passenger cabin and the counterweight. However, an elevator always has more cables than necessary, just in case. And what if there's a sudden power outage? The motor's self-braking mechanism fails, the worm gear breaks, and all the cables snap. The counterweight will free fall onto a shock-absorbing buffer at the bottom of the elevator shaft. The cabin will also free fall, but only for a brief moment before the final backup mechanism is activated. Below each elevator cabin, there is a safety brake controlled by an overspeed governor. The overspeed governor consists of a pulley, a centrifugal braking system, and a cable running along this pulley connected to the brake lever of the safety brake system below the cabin. When the elevator operates normally, the cable and lever move with the cabin, but when the cable's speed exceeds the limit, signaling that the cabin is in free fall, the two brake shoes inside the centrifugal brake will swing outward, locking onto the gears, causing the pulley and cable to stop abruptly. When the cable stops, it pulls hard on the brake lever, pulling the two brake shoes upward and clamping them onto a rail. This braking system is very powerful, and it will stop the elevator safely. But if elevators are really that safe, Why are people still so afraid of them? Look at it this way. In China, there are currently nearly 7,097,500 elevators, and in 2019, there were 33 elevator accidents, resulting in 29 deaths. When you compare the number of elevators to the number of accidents, you can say that elevators are very safe. 800 times safer than cars and 35 times safer than airplanes, according to statistics from the Technical Standards and Safety Authority of Ontario, Canada. The problem with elevators and airplanes is that whenever there's an incident, it attracts too much media attention and creates a resonant fear that's quite concerning. When you're sitting at home and read about the horrifying moment of an elevator swallowing someone in the news, it's hard not to feel afraid of elevators unless you're an engineer. We know how safe elevators actually are. Airplanes suffer the same fate. Every day, there are more than 100,000 safe flights worldwide, but because airplanes operate at extremely high speeds, any accident is usually catastrophic and imprints lingering fears in the public's subconscious. Back to elevators, it's a fact that most elevator accidents with casualties usually occur during construction or maintenance. Next are cases of people unfortunately falling into elevator shafts or getting trapped in elevator doors or between floors. In other words, elevators are very safe as long as they operate normally and passengers stay inside the cabin. Jumping when the elevator falls is a crazy idea. First, you won't know when the impact will happen to jump at the right time. If you jump too early, you'll hit your head on the cabin ceiling, and that's even more dangerous. Second, if the elevator truly free falls from a high enough height, you'll be in a state of weightlessness and won't be able to jump. Third, if the cabin actually falls and hits the ground at 100 kilometers per hour, even if you jump and reduce the impact speed to 90 or 80 kilometers per hour, it's unlikely to change the outcome. In reality, if the elevator really falls, the best thing you can do, besides praying, is to lie down on the floor and rest your head on your arms to distribute the impact force evenly. But don't worry, elevators are very safe. As always, remember to like, share the video, and hit the notification bell. Goodbye, and see you again.